means. This is a very common form of hypothesis testing. For example, if we think that gender is a causal variable and leads to differences in the evaluation of, say, gays on the one hand or the Republican Party on the other, we might formulate a couple hypotheses, a couple of gender gap hypotheses. For example, hypothesis 1, in a comparison of individuals, men will give gays lower feeling thermometer ratings than will women. Hypothesis 2, in a comparison of individuals, men will give the Republican Party higher feeling thermometer ratings than will women. These hypotheses suggest, the first one, for example, suggests that if we divide the sample up into two subsamples, one male, one female, and calculate means of the gay feeling thermometer, we're going to find that the male mean is lower than the female mean. Similarly, we would find in the same two subsamples that the male mean would be higher in terms of the Republican feeling thermometer than women. Now, the researcher always tests his or her hypotheses against a skeptical foil called the null hypothesis, which is labeled H0. The null hypothesis is sort of the champion of random sampling error. The null hypothesis says, look, in the population from which you drew these samples, there is no difference between the two groups, between men and women, for example, and any difference you do observe, no matter how large the difference, was produced by random sampling error when you took the sample. So we begin by assuming the null hypothesis is correct and then setting a fairly high standard for rejecting it. In fact, we call our hypotheses, and in fact these two gender gap hypotheses, we would label as alternative hypotheses, which would be labeled HA. As before, we're going to apply the 0.05 standard for rejecting the null hypothesis. To reject the null, we must be confident that the mean difference could not occur by chance more than 5 times out of 100. For p-values of less than or equal to 0.05, reject H0. For p-values of greater than 0.05, do not reject H0. Here's how to use analyze, compare means, independent samples t-tests. This is how you look for significant differences between two sample means. Here's the window. We put the dependent variables in test variable. The independent variable goes in grouping variable. I'm going to go down and find the gay feeling thermometer, FTGR gay. That goes over. Then we'll find the Republican Party feeling thermometer, FT rep. That goes over. Now, the independent variable, which goes in grouping, is gender. Here, it is always useful to review the codes because SPSS is going to want to know the numeric codes of the groups that you want to compare. I'm going to right-click on gender, click variable information, and just make note of the fact that males are coded 1 and females are coded 2. We'll see just presently why that's important. I click gender over. SPSS responds gender question mark, meaning what groups do you want me to compare? What are the codes of the groups you want me to compare? So I must click define groups. Group 1 are going to be males and group 2 females. So I put code 1 in group 1 and code 2 in group 2. Click continue and click OK. And we get a formidable looking set of output here. Let's take stock. Up here we have the group statistics. Here's the gay feeling thermometer. Males rated gays at 47.37. Women rated gays at 55.67. This would look like would seem to be a rather large difference. What SPSS did is it subtracted the female mean from the male mean and recorded the difference here, minus 8.302. Similarly, the male mean for a Republican feeling thermometer is 44.57, female 44.32, which is a rather small difference. Again, SPSS did the subtraction and arrived at the mean difference, which is 0.251. Notice that each comparison has 2 rows of numbers. One is labeled equal variances assumed. The other is labeled equal variances not assumed. The equal variances not assumed row is generally more conservative, so that's the one to to look at, and you can ignore the equal variances assumed row. So let's look at let's test the hypothesis about the gay feeling thermometer. Again, there's the mean difference, minus 8.302. That's 8 units of measure on the feeling thermometer, which is would seem rather a lot, or fairly a large difference. As before, an earlier module, we can see that the 95% confidence interval of the difference, we observed minus 8.302. Statistically, the difference in the population could be as large as minus 9.764 or as narrow as minus 6.840, but it is highly unlikely that the difference could be zero, as the null hypothesis is claiming. Does zero occur within this interval? No, it does not. Zero is quite a ways away, even from minus 6.840. To find out the p-value, SPSS calculated a t-statistic, minus 11.134, and then returned a probability value of 0.000. Interpretation. Under the assumption that the null hypothesis is correct and that random sampling error produced this enormous difference between men and women when you took the sample, we would see this difference, minus 8.302, 0% of the time by chance. So for the gay feeling thermometer hypothesis, the null hypothesis is safely rejected, and we can conclude that there's a very high probability that within the population, men do indeed give gays lower feeling thermometer ratings on average than do women. What about the Republican Party feeling thermometer? Let's go down here and check this. We saw the difference from a substantive standpoint was rather anemic. Indeed, looking at the 95% confidence interval of the difference, it could be as low as 1.175 or as high as 1.676. Does zero occur within this interval? Yes, it does. And since zero is the null hypothesis's favorite number, we cannot reject the null hypothesis since it's in that interval. If the null hypothesis is correct, how often would we observe a difference by chance of 0.251? Look at the significance value here, 0.730. It's gargantuan. Interpretation. Under the assumption that the null hypothesis is correct, we would observe this difference, 0.251, about 73% of the time by chance. So in this case, we certainly would not reject the null hypothesis.